The broadcast is now starting. All attendees are in listen-only mode.
Good evening. This is Peter Rustin with Tri-State Generation. It's just a little bit before 6 here. Thank you guys for joining. We'll give people some time, but just wanted to, I see some people are on, so just want to say thank you for arriving. And let me, we'll just take a few minutes here. So I'm going to go back on mute, but then I'll come back and I'll do a full introduction. All right, well, good evening, everyone. Peter Rustin from Tri-State Generation. I'm going to go ahead. It's about a minute after 6, and we've got looks like about 17 of us here. We did have 40 people sign up, which was really nice. We'll just go ahead and just get started, and hopefully others will join in. So, today is a little bit different. Normally, I'd love to be down in Telluride at the library with Kim and Jake, Wiley and Terry, Kim and Jake from EcoAction and Wiley and Terry from SMPA, and really talking to you about air source heat pumps and how this can really be a benefit in the SMPA's territory, whether in Ouray or San Miguel County or other parts. This technology has really changed and emerged over the last 8 years. So I feel bad that I can't be down there, but this is with COVID. There's no travel coming out of Tri-State right now, or at least limited. And so for tonight, usually I'd be a little bit more interactive. I'd be asking you, who you are and to help, maybe tailor some of the questions or some of the presentation material, and be more interactive. That being the case, today what we're going to do is I will kind of go over this webinar. I'll go over a section, and then a screen like the one that you're seeing right now will pop up, and I'll check to see if there's questions. And so if you look on your GoToWebinar, the third kind of field you can click on is questions. So you can either type in the questions or in the chat. At that time, I'll take a look at them. I usually, would have someone help me, but we're at 6 o'clock tonight. So I'll take that pause and answer those questions, and look forward to a good discussion. Any question is a great question. There's no basic questions. So this is really about a kind of a heat pump 101, and showing how we can make a difference, both from reducing carbon, saving people money, and really making people more comfortable in their homes. So with that, I'll, kind of start the presentation officially, and tell you a little bit about Tri-State. If you don't know who Tri-State is, we're a non-for-profit association of 45 members that include 42 electric cooperatives and public power districts. So we're a power supplier that we're owned by these 45 members. SMPA is one of the members that owns Tri-State. Together, we work together to deliver reliable and affordable power to over 1.3 million rural electric customers. And the area that we cover is huge. It's massive. It's all the way from Montana down to the U.S.-Mexico border. Our primary states are Wyoming, Colorado, New Mexico, and Nebraska. But we also, like I said, we have some stuff that comes in from Arizona, Utah, and Montana, a little bit into Kansas. So we have a lot of spread out quite a bit. We don't have a lot of people per line mile, but what we do have is a lot of great people. And it's not just at Tri-State, it's our members. And you have a great staff, and you have a great partnership with great staff at SMPA. You have a great partnership with EcoAction. To give you a little bit of background about myself, I'm a relationship manager at Tri-State, and what that means is I help manage the relationship for 14 of our 42 members. I serve a couple in Wyoming, but I mainly serve here in Colorado, which is great. I've actually started working, probably 12 years ago in energy efficiency in Colorado, and at that time, I was at the Colorado Energy Office. So I used to help provide grants to the New Community Coalition, if you remember that, which is now EcoAction. So I'm very excited to be talking to you, everyone here. And, if you have questions about me or Tri-State, feel free to email me, or we can ask questions later on that. So the goals today, are really 3 things. Know how the cold climate air source heat pumps work, the benefits that are there, the different applications. Not everybody goes in the same house, so we have different systems for different homes, and really how to get started. How do we take this information and actually implement it realistically if we're thinking about a retrofit, or if we're thinking about building a new home. So I kind of want to start off with not air source heat pumps, right? When we think of heat pumps, you might be thinking, well, is it a ground source heat pump where we're taking, energy out of the ground and bring it into the house, or we're using water as a source for that heating or cooling load? Tri-State has some great rebates for these technologies, but today what I'm really going to do is focus in on air source. And so when we talk about air source, what we're talking about is pulling BTUs out of the air. I know it sounds crazy, but even when it's -5, it's -20, it's -50, there's still BTUs floating all up in the air. And so how does the air source heat pump work? Well, it doesn't create heat, but what it does is those BTUs that are floating in the air, it grabs them and it pulls them out of the air, it condenses them, and then it brings it into the house, transfers the heat, basically just grabs it, condenses it, pulls it, and then uses the heat exchanger to get it to your furnace or to a wall cassette, and that goes ahead and heats your home. You might think about an air conditioner, right? So what a heat pump is an air conditioner in reverse. In the summertime, an air conditioner is grabbing those BTUs that are floating in your home, condensing them, compressing them, taking them out of the house, and letting your fan blow it out into the atmosphere. And so basically, it's an air conditioner that works in both ways. Um, it's there's nothing else really besides that. It's using the air. It's not using the ground. It's not using water. It's using the air to grab its BTUs and keep your house, whether it's cool in the summer or warm in the winter. So you might have heard them in the past, and you might have heard it from someone. Maybe people from Texas moved to Telluride. I don't know, but maybe they heard about heat pumps and told you about it. And this is an old 2012 map, right? This is where they'd sell it to you. Heat pumps only work in the South. They only work in California, Texas, Florida, where you have a cooling dominant climate, and you might get down in the 30s once in a winter. So people said they don't work in the cold. Well, it won't save you any money compared to propane or any other type of heating that we have. Oh man, if it gets cold out, it just blows cold air. Propane and natural gas are more reliable. Natural gas are greener. Well, the interesting about, especially on those last 2 points, is that, well, people forget that in our modern propane and natural gas furnaces, we have air handlers and motors to blow, variable motors that help heat and cool our house. When those go out, when the electricity goes out, those don't work. Therefore, you can get fuel to your propane or natural gas furnace, but you're in a power outage, your electric furnace won't be working. And the nice thing about propane or air source heat pumps is they run on electricity. And between Tri-State's commitment to renewable energies, SMPA's local projects, you guys max out your local projects. We're definitely a greener than propane or natural gas in terms of that carbon content. And Tri-State recently, we have opened up a new contract opportunity for our members to add even more local supply, so more renewables. So, this year we were a little above 30%. In 2024, we'll be at 50%, and we'll continue to grow. So it's going to keep on getting better and better. So how does this work, right? So how did we get from, man, it's only in the South to, I'm talking about putting it in climate zone 6 and 7 in San Miguel County or Uray County, where, frankly, it's some of the coldest climates that we have in Colorado. This key breakthrough. So what happened? Variable inverter technology. So when I talk about cold climate air source heat pumps, you might also hear the terms variable, efficient, inverter heat pump. All it's meaning is that this is the technology, that variable inverter technology. What happened is the pump and the condensers and the motors that work in these machines, they match the house load. So if it's 50 degrees, maybe it's running at 10%. As we get down to 20 degrees, it starts to ramp up. Maybe it's at 50%. And then if it gets to 5 or -5, it might be running 90 to 100%. And so what that does, it carries that performance over a band of range of temperatures. Old heat pumps, they come on at one power. And so it was designed to heat the home at 40 to 37 degrees, and you got your maximum BTUs. This inverter technology, what is great about it, is that being able to vary the amount of energy that's, or the amount of power coming out of that motor to condense that air, and it can match that house load. So yes, it can give us full heating that we need at 40 or 50, but it's not running full time. As we get down to those colder and colder temperatures, it's able to run, more and more and really heat the home. And then on the cooling side, it does the same thing. I know we're not really talking about cooling in SMPA's territory, but it can cool a house relatively easy at maybe 70, 75 degrees. Again, maybe it's running at 10, 20%. But as we get up to 95, 100 degrees, it's running at 100% to cool that home. So you get this really big range of temperatures that it can serve. And not only does the inverter allow the air source heat pump to serve cold loads, it allows it to serve it efficiently. And so on the scale here, what we're looking at is those heat pumps that I talked about in the South, these old school, they get you down to about 30 degrees right here. But then you need some sort of backup heat right here, right? You need to have propane, you need to have electric resistance heat, you need to have natural gas, something else to help keep your house warm in the winter. Well, then the inverter technology started coming along in the early 2010s. And okay, so we pushed this back here. Okay, now we're down to about 20, maybe 15 degrees. Now look at this cold climate heat pump. Okay, this is really mature technology. It's coming through. All of a sudden we're at 5 to 10. And notice we're at 100% here, but even we get down to 0 and 5 degrees, -5, -10, we're roughly at 80% capacity. And yes, we need some backup heat, but with the ability to have this variable load in some of the sizing that we can do, we can match the load, but we can play around with a little bit that we can oversize it a little bit on the cooling end, so we can get farther and farther down there. So maybe you might need a 4-ton unit to keep it at 100%, but maybe we could put a little bit something, down here at 4 tons to keep us warm, and we wouldn't use it all over here if we needed to cool the home, even though it's on 30. But theoretically, we kept on going out on that scale. So again, I'm going to stop here in a few minutes. If you have questions on it, happy to go into that a little bit more. So, as talked about, look, we can get down to 5, -5, -15. Well, this Mitsubishi technology, that is, this actual is from 2 years ago, this image, down to -25. Now, I know Telluride's had their coldest day on record was -38. Uray was -21 or 23. That's in the history. So these things can carry a home in cold weather, and it can carry a home in your service area, in your territory where you live, which is really nice. And so again, this is all about keeping that performance out as long as we can, and it starts to dip a little bit. But again, the technology is there where we can carry it down to -25, whereas a conventional heat pump would just drop off. So there are different types of cold climate air source heat pumps. You guys might be familiar with the mini split, where you have this really skinny condenser compressor out in the outside next to the house, and then you have a wall cassette that's maybe up, hanging on a wall that's controlling one room or 2 rooms, making it comfortable. So this is called a mini split. Mitsubishi, Fujitsu, Daikin, those are sort of the Friedrich, those are some of the big names in mini splits. Then we have what calls a ducted mini split, and this is actually what I have in my house. Again, so it's very much like a mini split where you have a skinny condenser, but goes into an air handler. And so within that air handler, then it runs through mini duct work, and you can have your typical registers. And so, why this was important in my house, you can have these cassettes, or you could even have some ceiling cassettes or some wall mounts. My wife really wanted registers in the floor, so we went with a ducted mini split because that's what fit our need for our home. Note though, these are not quite as efficient as the mini split because you have airflow going through here. So in these, there's a little hose that comes up, a little pipe, and then you get your air right out. Your refrigerant and the compression is all right there. With a mini split, it gets it here, right? This is similar to that cassette. And then the air has to be blown out to the room. So it's not quite as efficient. So that's a mini split, ducted mini split. And the other one that is really popular is called a ducted or central cold climate air source heat pump. And this is what they look like. And so to make them really efficient, what they've done is they made the coils bigger and bigger. And so you can see it's like a giant air conditioning unit that you would see at a home. This is what's able to heat and cool your home. The great thing about this product is even though that this unit is really large, the air handler that matches with this system is the same as a natural gas or propane furnace. So if you're doing a retrofit, it can fit right in that exact space that you have in your current furnace room. It's not anything bigger. The only thing bigger is this unit on the outside. And it's bigger because it's more efficient. I know it sounds kind of counterintuitive, but that's how you're able to make central ducted is by making it bigger and bigger, whereas the mini splits, you go smaller and smaller. So there's also some additional cold climate air source pairings. This one right here, it's called a heat pump with an ETS. So, your heat pump will run and run, but then kind of come into here and blow through your typical ductwork. This is with a central air source heat pump. So, this one is where this system is paired. And then this is called an electronic thermal slab. And so these are just bricks that when there's off-peak time, so if you're on the time of use rate with SMPA, or if you are switched to a demand, going to a demand rate that you chose, in your off-peak hours, you can store that heat, and this can be your backup. And between the two, you can miss your peaks, you can be more efficient, and so not only can you save money, but you're also helping your utility also reduce their overall costs. The next one is air to water. So this one is an emerging technology. Most of the manufacturers are in Canada or from Asia, but I know there are a lot of radiant in-floor radiant homes in your area. And so this is why I wanted to bring this one up, is that you can actually hook up an cold climate air source heat pump into a radiant system. It's really for applications with not a high water. So we're not talking about a home with a boiler and fin tubes that need 180 degrees, kind of that baseboard hot water to keep your house warm. It won't work. It won't be able to carry the home. So it's really for radiant in-floor homes in a retrofit application, or for new homes, but I'll get into that. So some foundational information. Both the air-to-air ducted and ductless units. They can be used in a single or multi-zone configuration. They can be utilized in new home construction or retrofits. They're rated in SEER and HSPF. So HSPF is more important in cold climates, such as Mountain Village, Ridgeway, as opposed to, say, southern New Mexico in our territory. The good news is, though, like SEER, the higher the number, the better. And when you're seeing something, I brought this rating up because you'll see it on a heat pump, but just remember, higher is better. And typically cold climate heat pumps have a SEER greater than 17. And for ducted systems, they have an HSPF above 9 or an HSPF above 10 for non-ducted systems. And they go in parallel. So just remember, higher is better. If you see something above 17 SEER, you're in really good shape. But again, if you see it, don't be like, I don't know what this means. You don't necessarily have to worry about it. Just remember that SEER. Air to water, it's rated in COP. It's a different performance metric. That for Tri-State, you don't really need to know if it's a air to water application. It qualifies for our incentives. Same thing though. The higher the number, the better. You'll see those in the 2, 3, 4 ranges. Just to give you a sense if you do see one. What we do know is that no matter if you try air to water, a ductless mini split, a ducted mini split, any way you go, you're going to reduce your energy spend compared to traditional heat pumps. You're going to reduce your energy spend compared to electric furnaces or baseboard heat, and also this compared to propane, it's a slam dunk. So that's our foundational information on air source heat pumps. So how do I use this, or where do I use it? So if you have the ducted, again, that's the one that's really big that goes on the outside. Anybody in Southwest Colorado that has a propane heated home should have an air source heat pump. So if you see someone that's building a propane heated home or thinking about it or has it, they should have a cold climate air source heat pump. They already have the ductwork for this to fit in really easily. If you know someone that has air conditioning, I know it's not really common in the Southwest right now, in Southwest Colorado, but if someone's going to replace their air conditioner, if you're thinking about it, go ahead and get an air source heat pump. You don't need a cold climate one. Just get an air source heat pump, and you can pair it with your natural gas furnace. You want to make sure your brands match, and you want to, you get the most out of it if you have a variable speed blower in your furnace. But if you're thinking about that as a homeowner, ask your contractor about air source heat pumps. Remember that your brands need to match, and then just ask them if you might not know if you have a variable speed air handler, but just ask them if you do. Any home or small business with existing ductwork is a great candidate. And then, as I say, you compare it with an ETS to maximize. That's like electronic thermal slab, electric thermal slab that stores energy at night. Um, you can use that. You can maximize your savings if you're on the general service or three-phase demand time of use rates in SMPA service area. Ductless mini splits, they are great if you have an electric baseboard heated home. Home additions. So this is how I got into. There's a few reasons we're going to talk about why I have a cold climate air source heat pump at my house. But one is an addition. So I have a growing family. We needed more space. We added on, and it made sense at that time for us to put in a cold climate air source heat pump because we didn't have to run more ductwork. From our furnace, it couldn't be carried over, and it allowed us to put in basically a cheaper install because we got our air conditioning and our cooling and our heating out of one system. This is also great for rooms or areas that you have problems within your house. So is it a basement? During COVID, a lot of us are working out of our home. So, this is, if you're in your basement, this is a great way. You can get a 9,000 BTU, that's about 3/4 of a ton, Mitsubishi, hang it in your office and have complete comfort year round, both heating and cooling. Or if you have, above a garage, right? I know if you have people coming in, you have a split level house, especially in your cold winters, you might get a room over a garage that could be a little bit colder than the rest of the house, and you don't have enough heat or enough ductwork to get heat back there. Well, here you go. You can add this on and put in for one room, and have a air source heat pump be able to heat and cool that home, or heat and cool that room. It's also great new construction. So this is, if you work with a builder, if you're thinking about building a home, or if you know a builder, ductless mini splits will reduce the cost of that home. So I don't know. I know affordable housing is an issue in the area, like many of our mountain communities. If one's going up, they should be looking at air source heat pumps because that can reduce the cost, especially the ductless, because you're not running ductwork. You're hanging on the side of the building, and you're able to heat and cool that space. You can run some ductwork. It's a little bit smaller. Like I said, that's what I have in my house. Again, it might use some of that benefit from the not having to run ductwork in terms of cost. But what you do get is that you get a technology and a piece of equipment that will save you money over the long term. And the other one that we really see with ductless is schools, even with natural gas boilers. So we have a couple schools down to the southwest of you in Montezuma County that have added cold climate air source heat pumps. And they still have the natural gas there in case they really need it. But what they really do now is they have it in each room. They have one ductless mini split. It heats and cools the school much better, because in a typical school with a boiler, maybe a 2-story school, you have an east and a west, or a north and a south, and you have 2 levels. So you only have 4 zones. And so typically people are really warm on one end of it and cold on the other end, or vice versa. So they've been able to put these in, increase the overall comfort of the student, which improves the learning environment, which is a great benefit. And then with COVID, what we've seen this year is in those mini splits, you can bring in fresh air that's not being mixed with other classrooms. So there's some other potential health benefits there. And so that's why I think it's a great technology that we can see with schools. The last one that we see sometimes is air to water. And then again, this is what I'm talking about, those radiant heated homes. That's really the only place that you can retrofit them. If you have a baseboard hot water heat or radiators in your house right now, this won't work. It cannot get the water to a temperature that would help heat your home, 150, 180 degrees. In some cases, it can get up to 130, which is great. You can use this to get your domestic hot water. In new homes, you can use it with radiant heat, and also if you see here, you can use it with radiators, but they really have fan coils with them, and so it's a little bit different. The nice thing, if you do these radiators, that actually can do a dual system where you can bring cool water in there and hit those fan coils and actually cool your home. but that's really only for new homes. The other thing that we struggle with on the air to water is there's really not a lot of equipment options. I can go today to York, Rheem, Mitsubishi, Crane, Carrier. They all carry some sort of cold climate air source heat pump that is an air to air, mini split or centrally ducted. The air to water, there's only 5 manufacturers that serve the United States. We do work with them, but again, it's not quite as popular as our other technologies. So with that, I'll look to see if we have any questions. Okay, it looks like Katie had a question. Can we retrofit our natural gas furnace, which supplies our hot water baseboard heat with this technology? And unfortunately, Katie, we cannot do that, as we just sort of talked about. The you know, I wouldn't even say that it's a way to help offset your natural gas bill. I would say that your best bet might be adding solar thermal to help reduce that natural gas bill and help preheat some water with your baseboard heat on that one. The next question I had, is there any place for ground source heat pumps anymore? And yes, there are applications for ground source heat pumps. The air to air has definitely become more common. It's much easier, especially on a single home. But when you start to look at a neighborhood and at a development, say a master plan community, there's definitely an application for doing a shared loop system. And that is something that, if you go back to the East Coast, specifically New England, some of the larger natural gas utilities see the writing on the wall, and they're starting to look at being able to use their kind of business model to do more servicing of geothermal and shared loops, with their lines. So there is still a place for ground source heat pumps. I think on an individual home, it's harder and harder to make that case. But that's just, I'm sure there's people out there that would disagree with me. And again, we still support that technology. It's just tough for me, I just went through that process at my own house. So that's where I get my insight from. I will share a list for people that are interested in that air to water. There's a question, can I share that list? Yes, I will share the 5 manufacturers. I will send out this presentation, and I forgot to say this at the beginning. This is being recorded, and so I'll work with Jake and Kim at EcoAction to make sure it gets posted, so you can go ahead and, hopefully this is such a great presentation you want to watch it again. But if you know other people in the community that do want to watch it or have questions, and maybe we could take some snips out of it and have some different videos for people. So, all right, those are the questions that I have right now. I'm going to go on the next section. So ducted system deep dive. Tri-State really believes in this technology. And what we wanted to do was really make sure that it worked for our members and the end use customers. So your member owners of SMPA. What we really wanted to do was verify that, one, the equipment works at low temperatures, and then also that it could be cost effective between conventional propane and natural gas units. And so we partnered with EPRI, and we ran a field study between 2018 and 2019. There's additional utilities across the nation are participating in this study, but we finished up first, and so we had our results. EPRI is a research entity, and they support the electric industry on everything from EVs to hot water heat pumps to solar. They help gather us information and do studies so we know that it's something that our consumers would be able to utilize. And the nice thing about this is we were actually able to work with our members and member homes to do the study in 5 locations. So these are our test homes. We did 2 in Nebraska, 1 in and 2 in your area, 1 in Cortez and 1 in Bayfield, and we had 1 in New Mexico. And we want to make sure it worked out throughout our service area. So we tested at different areas. Here you can see the original HVAC equipment. So we tested a variety from someone that had propane, an old school heat pump, an evap cooler with a natural gas furnace, another propane, and then you can see the types of equipment that was going in. It was all Carrier Infinity heat pumps. These are the Sears. Remember I said Sear and HSPF sort of go hand in hand. Here it is, 19 and 10.5. This one's a little bit different. So they could be set up so the Sear's not quite as high, but so in cooling it might not work as efficiently, but definitely in heating it is at 11. In this study, this is our central ducted systems I talked about, and they typically have those backup heaters. I guess I maybe skipped over that point, but so in our ducted system, one thing to know is that they typically have a backup resistant heat. So for early adopters, it might be a nice comfort that you have this. If you don't feel there's enough heat in the house, that electric strip can kick on. And so we had 15 kilowatt heat strips that were put in there. 1 out of 5. This will vary. In terms of added cost, a 15 kilowatt supplemental heater is about $150. This 5 kilowatt is $97, so not a whole lot of costs added on to an install. So we tested it over a year. What did we learn? Right? We know they work in our 4-state service territory. I wouldn't be here talking to you tonight if we didn't think they were going to work. They provide opportunities for co-ops and public power districts to not only help grow their load, but also reduce consumer costs. And one thing I really haven't talked about, but I said I worked with all the way back to the New Community Coalition. I'm a big believer in energy efficiency and finding ways to reduce rural energy poverty or rural energy burden that we do find, throughout our system. And this technology really can. So when we talk about this new emerging technology, and I think it's great. It's like almost like a new iPhone. At the end of the day, this can really help people save money, which is awesome. In terms of what else we learn, proper equipment sizing, making sure that you have air sealed your home and insulated is always your first step. It's kind of a no-brainer. And then consumer education are important. So we had a person that was like, man, my electric bill is up and I thought I was going to save money. Well, they forgot that they didn't have a propane bill anymore. So it's educating them that their entire utility bill, both electric and propane, electric might go up a little bit, but overall you're going to save some money. And so this is from Site 1. I know this is Nebraska. I don't have this information yet for Corteza Bayfield, but what we did is we, from our study, if we had an air conditioning with a propane furnace, typical setup, this is what in heating system and cooling, this is what it costs to run that system for a year at $1.15 a gallon propane. This is what it costs at $1.85. Now I did a presentation yesterday and I was made aware that the September price in Ridgeway for propane delivered was $2.60 a gallon. So these numbers are Nebraska, not quite for your area, but just keep that in the back of your head. Then to run that variable speed pump all year was $735. This is what that cost in that service area was. And so this is what you would save, right? If your propane was $1.15, you'd spend this much to run it versus this much for your electric heat pump. This is what you'd save all the way up to $1.85 a gallon. So if I'm thinking about where we are now in San Miguel and Uray County, we're probably closer to saving $1,000 a year, at least with a air source heat pump. Simple payback. Cold climate air source heat pumps do cost a little bit more. So about a $5,700 cost premium. We have our incentive. SMPA also has an incentive. So, this cost would be a little bit less, but our premium with the incentives taken out is about $4,300. And you can see the paybacks from 13 years to 5.2. Obviously, if you're paying $2.60 a gallon in your area, we're pretty much almost at a 1-year payback, if not 2 years. So it's great. So I keep on talking about propane, and why is that? Well, here's a map of San Miguel Power's service area. Got a lot of propane down here. I mean, this is obviously very important for Tri-State. We have a lot of propane members in Nebraska, even Wyoming, New Mexico. But in terms of Colorado, there is a ton down here in the Southwest. And I think, again, we know this saves money against propane furnaces, and it's a way, especially right now, to help people save money. So I know not everybody was, obviously I talked about Bayfield, New Mexico, Nebraska. We didn't have a home in Ridgeway. We didn't have a home in Mountain Village. We didn't have a home in Telluride. So what we did ask is we asked EPRI outside the study to run an energy model for a 2,000 square foot home in Cheyenne, Wyoming. A home built in 2009 with 2009 installation levels. So think about that 2009 energy code that was about a decade ago. And again, this calculator, it gave us a lot of information. It gave us our energy usage for the cold climate air source heat pump, if we had an 80% efficient furnace or a 93% efficient furnace, and then the cost per unit. Again, this does not reflect your actual cost, but we're about half the cost compared to an 80% efficient furnace, and this propane furnace is about 93% efficient. So what's neat about this is we know it works in all these different climate zones. The biggest takeaway from this slide is that we're developing a calculator. And I will work with Jake and Kim at EcoAction and Wiley and Terry at SMPA, and we'll help tailor the savings information based on the rates that SMPA has, the cost of propane, and the actual usage during heating season. And the neat thing about this slide, you are colder than Cheyenne, and we're already seeing this divergence. Your propane is greater in terms of cost. So we're going to see some really big benefits, I think, once we get that calculator out to you. So I did mention, propane furnaces, ductless systems, and I sort of said it's tough with natural gas furnaces, but in that air conditioner backup could be. So right here, it's an air source heat pump, sort of that old school that I talked about in, Texas and New Mexico versus a cold climate. So you might also hear them called dual fuel, is another name for these typical regular air source heat pumps. While they aren't as efficient as an cold climate air source heat pump, there is still an application in San Miguel Power Association's service area. And the reason is, in that one slide I said they carry to about 30 degrees. Well, I think most of you probably heat your home between 30 and 65, 68 degrees. So you can use all this time that you're trying to heat your home, you could be using an air source heat pump. And then once you hit that 30 degrees, it automatically switches over to that natural gas backup. And so again, even though I said we don't really see a lot of applications for natural gas heated homes, if you have an air conditioner and you're thinking about replacing it, you should go ahead and put in an air source heat pump. Doesn't need to be cold climate. I would love it if you did a cold climate. I can't tell you it's going to be cost effective compared to a furnace because natural gas is so cheap. And again, with that EPRI study, we grabbed that information and we added that if we did an air conditioner with natural gas furnace, here's the cooling is about the same, but then heating, typical furnace can be about 110 MMBTUs is what they would use from that in terms of natural gas. If we have the heat pump, we obviously reduce that, but our kilowatt hours go up to 3,700. And you might ask me, well, why do I have kilowatt hours if I'm heating my home? Well, remember, you have a fan and an air handler with your furnace that requires energy to push air throughout your home. And if electricity goes out, it won't work. That's why I was saying that, because you always have to have that electricity to run your furnace. Okay, not quite cost effective, but if you are green and you want to be green, go with a heat pump, or, as I said, have that air source heat pump instead of a cold climate, and you'll be able to help save some money during the shoulder seasons. So support is the next section, but before I get into that, I'm going to take a look at my questions. All right. I do have a comment from one of my friends in the utility world that they have a contractor who said they can replace a boiler sidearm with a heat pump. They're going to use an Arctic heat pump in a couple homes, and looks like using a Bosch furnace. And I do think that that is correct. So that those Arctic air source heat pumps can be used to heat your water or domestic hot water. They can be used to be used with your you're rating for heat. Mary, I'm going to give you an email here. I just want to make sure if I understand this correctly. It sounds like they're still using a furnace as well, or a boiler, but for the group, learn something new every day. I will talk with my colleague in the utility world, and we will understand how if this is an application. When I email everybody in a couple of days with a presentation, I will include that. So another question is, what about natural gas? Kind of went through that. It's not quite competitive unless you have replacing an air conditioner. Snow depth. So this is a question that does come up. It reached over 5 feet in the last 4 years, your snow depth. And how do you avoid that snow accumulation issue? And so what we have seen, because we also have Mountain Parks as one of my members, and what they've done, Mitsubishi, Daikin, they all sell these. They have stands that match their model, or anywhere between $100 and $150. So what you'd want to do is put that compressor on a stand above that snow depth line. And your contractor will want to make sure that's level for proper performance. But yeah, snow depth is a big one. I know some people do worry a little bit about things freezing up. That was with maybe an old heat pump. The new technologies that we have here have pan heaters for the mini splits, or they have a defrost cycle, so they're not going to ice up. And as long as you keep them up above that snow depth, you will have no problem with them in wintertime. So those are the last questions that I have on that one. So support. How are we going to do this? So we've learned a little bit about air source heat pumps, a little bit about their application. Again, I know it's a lot of information. I'm going to give you my email at the end of this. Always feel free to email me any questions. I will also say I did not put Jake and Kim Wheels information on there from EcoAction, or Wiley or Terry from SMPA, but you guys have an awesome, unbelievable staff down there that's very knowledgeable, that can help you figure out almost any different situation you're in. I'm here to help answer any question. I'm always open with that. But just want to know you guys have a great resources. You're very lucky to live where you live in terms of energy efficiency. And also it's pretty down there. So incentives for air source heat pumps, cold climate. Currently, Tri-State offers a few different incentives. We offer 300 a ton for units rated 15 to 17 SEER. That's mainly for our New Mexico customers. As I said, once we get to a cold climate, we're typically above 17 SEER. And for those units, we offer 450 a ton, not to exceed 50% of the equipment costs. And then if you did that backup I mentioned all the way back at the beginning, and having an ETS as your backup, we also offer $100 for that equipment. The great thing, again, you guys live in a great area. SMPA and EcoAction, they actually match Tri-State's 450 a ton rebate for those higher SEER for the first 2 tons. So what does that mean? So if you have a 2-ton heat pump, you earn a rebate of $1,800. That 450 match, so that's $900 a ton. And then for a 3-ton heat pump, you earn $2,250. It makes a big difference. And so that is money that goes to the consumer. It goes onto your account and helps you reduce the cost of the actual install. So I gave you the amounts, but what does that impact? So here is about a 3-ton unit from Daikin. I went to National Air Warehouse. You might work with suppliers that can get cheaper. This is a sort of a standard one I use. This equipment is $4,100. And what does that get you? That gets you your outdoor condenser, 1 wall cassette or 1 ceiling cassette that I mentioned. That's about 12,000 BTUs. It might heat 1 or 2 rooms. Then you get a wall cassette that's about another 12,000, kind of eating into this 39,000. And one that's 15,000 BTU. And this could probably heat a good size, maybe, again, you want a heating load calculation done. But I bet some of your smaller homes in the area, this is what you would need. 17 SEER, almost 18. Here's the price after the rebates of $2,250, less than $1,900, complete system to heat your house, heating and cooling. You can't beat that. And this is the ductless mini splits. Ductless mini splits are unbelievable technology. They're really easy to install, usually about half a day, as long as you have electric room in your panel, and they solve a lot of problems. If you have a new home, typical costs, you basically spend about $4,800, $4,900, and this is if you're going to put in a Rheem 95% efficient furnace, 5-ton, 70,000 BTU, a 5-ton matching air conditioner, 14 SEER. You might not be going that big on the SEER. Here's your cost for that equipment, $4,900. Atmos, Black Hills, they do have rebates about $100, $150, so this might come down a little bit. Cold climate air source heat pumps for this 5-ton unit, $4,600. Yes, the equipment costs $7,800, but we've got that $3,100 rebate when we do it by ton. And look, you got a 19.5 SEER going in. So you're going to be saving money in the wintertime, you're going to be saving some money in the summertime. So while you're also reduce your total installation costs. So if you're building a new home, look at a cold climate air source heat pump. Again, ductless will save you a lot of money because you're not running ductwork, but centrally ducted, if you like that, you can go that route as well. One other thing that we're doing is we're developing a quality install program. So if you're a contractor, an HVAC contractor, or you're a contractor that works with HVAC contractors, or you're a homeowner that knows a contractor, let us know. Any installer can work in SMPA. This is our pilot program. This next year, they get $250 per install if they meet the quality install program requirements. In addition to those rebates I just mentioned above, it's really easy to participate. We've got a 2-hour sizing webinar. We've got a half-day webinar coming up that is mandatory from 1 to 4. So if you know them, let us know right away, and they got to complete a form for us. It's pretty easy. We're piloting out in SMPA's territory. I've said I got a long relationship all the way back to 2008, 2010. And I know we can really do some great things down there with the support that both SMPA and EcoAction provides. And look to see if we have any questions. So the example costs, no, they do not include installation. So when I look at that, I will, I can pull some information. I typically see for ductless systems between, 600 and 2,500 for an install. Ducted systems are a little bit more per install. And ductless, it can really vary, right? If you have a really simple 12,000 BTU, it hooks right into your electric panel, you're fine. If you need a little bit more work, or if you're going to go over your transformer limit, it gets a little bit more, each house is different. But call Jake, call Kim at EcoAction, get yourself set up with an energy audit, and they'll help you walk through that. I do have a question come in about DMEA incentives. I do not. We separated with DMEA on July 1st of this year. I have a lot of friends over there. I just don't know what they've done with their energy efficiency program. I know they do a great job at DMEA. Go ahead and give them a call or look on their website, and I know they'll be very happy to help you out. All right. So other considerations. So this is it. Again, this is an hour, and I appreciate everybody sticking through this. I know it's a lot of information. So our other considerations about, it's not all about, saving money. It is a main driver. I did talk a lot about helping this technology helps eliminate that rural energy poverty, especially in propane heated homes. And that's a passion of mine. But there's also something else that's at work here. Because it runs electricity and you're not combusting any gases like you would with a propane or natural gas furnace, you're eliminating part of your carbon monoxide poisoning risk. You might have your, a hot water heater that's still served by that, but if you're taking out your heating system and changing it from propane or natural gas to electric, it's getting rid of one major source. I have the CDC note here that 34% of all non-fire carbon monoxide poisonings were from a home heating system. Cars are number one at 42%. But again, yes, there's some other appliances or some other things in your house that could lead to that, but your home heating system is one major one. And if you're going down that route, think about changing out your hot water heater to an electric heat pump. There's also hot water heaters at electric heat pumps and are a great way to save not only money, but also help protect your family. And so this is, I said there's a lot of reasons why we went with an air source heat pump at my house. And one, yes, it was cheaper to put in. Two, it was our furnace, we couldn't run the ductwork over anyways. And the last one was I have three kids under 4 years old, another one on the way. And there is, we are safety to the max in my household, and we wanted something all electric because we worry about it, right? We have one in our basement. We don't have, we don't know where everybody is all the time, and we have our CO detectors, our fire detectors, and we want something that we could make ourselves live more comfortably at night, knowing our kids were safe. Another benefit that I heard about yesterday was, it eliminates or reduces the need for exterior propane storage. Wildfires are becoming more common. It is something that is another way to help fuel fires is having propane tanks out there. And it got really real for me this last week. I said Mountain Parks is my one of my members I have a relationship with, and I manage that. 3 employees lost their homes in the East Troublesome fire. And, this is something that obviously that is way beyond just a propane tank. But again, anything that we can do to make our homes more defensible and safer, I am all for. And speaking of wildfires, the nice thing is, I used to live up in Avon, Colorado. Every summer, I would open up my windows and let the cool air come in at night and cool the house down. We never had any air conditioning. My brother just put air conditioning into his place because they cannot, they can't keep their windows open all the time with some of the heavy smoke coming from the forest fires. So really to be comfortable with air infiltration, and turning to cooling is becoming more and more prevalent. Another nice thing about this is that they're really quiet. It's about 40 to 60 decibels. Ours runs constantly, you never know it, compared to 60 or 70 for a typical air conditioner. So that's really nice. Real estate transactions. So some of you guys that know me, this is like my bread and butter right here. So I worked on all the time at the energy office. This was just great timing, I thought. This is one of the first presentations I did actually at the Telluride Library back in 2014. It was on the green MLS and what Telluride was doing. But there was a study that was completed by economists that said that efficient or cold climate air source heat pumps increase the value of U.S. homes between $10,000 and $17,000 on average. It was published in the Nature Energy Journal this last month. It wasn't appraiser driven. It doesn't take into account to the local markets that you have in your area. But this is what I loved about it. This is how it started with the PV solar market. So in the early to late 2000s, we started to have researchers and academics put together studies that were trying to link PV value to home price. And they were making some connections, but no one really paid attention to it. But then appraisers started doing these studies, and now we know that solar PV increases the value of your home. And so this is what I'm really excited about is we're seeing the same pattern with academics starting to look at these efficient air source heat pumps. Eventually, I'd like to connect those dots to a higher home value. Commercial buildings, if you know someone with a commercial building already, appraisers, they value home-built commercial buildings with an income approach. Since this equipment will reduce the operating costs, it will increase the value of a commercial building. Just another bonus of why to put an air source heat pump. You will save money. You will make your home make your home safer, and in the long run, you might make your home more valuable. And definitely for commercial buildings, you already are. So, anybody ready to get started? Well, best way to do that: get an energy audit through EcoAction Partners. As I said, while this is an amazing technology, we always go back to make sure that your house is sealed up, insulated at proper levels. That could be R49 to R60 in your area, and then get it properly sized. Have Kim Wheels, Lotus Energy Services will be able to do a manual J and size that heat pump for you. Some contractors will be able to do that as well, and make the heat pump fit your actual home. I always say go big, add in a heat pump hot water heater, and really add to your savings and home safety. Again, I get this could be a large investment. Even after rebates and install costs, we're probably looking somewhere between maybe $8,000 to $10,000 if we're doing a hot water heat pump and everything. In your area, Alpine Bank offers an energy loan. And there's also a program called Renew that's sponsored by the Colorado Energy Office. Go to EcoAction's website. It's all listed there. If you're a commercial building owner, I believe Renew works, or Alpine Bank works on that, offers money for energy efficiency for commercial buildings through their program. And then there's the PACE program that the San Miguel County Board implemented and adopted. The last thing that you can do, so you get your home all electrified, hey, make it renewable. So I said about 30% of electricity, a little bit more is currently being sourced from renewables, going to 50% in 2024. Well, right now, SMPA through the Green Blocks program, you can make your electricity 100% renewable for about a penny a kilowatt hour. So in that example I gave up above, that you'd add about maybe 5,000 to 6,000 kilowatt hours on your utility bill compared to a propane furnace or a natural gas furnace. Well, that translates to about $60. So for about $60 a year, you can make your heating and cooling completely green and renewable. The last thing I want to touch on, I know we're kind of coming up to 7 o'clock. Again, I've mentioned a little bit about rural energy poverty, how important it is to me to be working on that. SMPA has an income qualified program. It's called the IQ program. You may have seen the logos, or it's sometimes called CARE because it's help funded through Energy Outreach Colorado. It's managed by EcoAction Partners, and it's a really important program, especially when we're talking about being in a pandemic. We're not sure about what's going to happen with, jobs. Some people have had jobs lost. And they provide a free energy assessment. And if some things could be replaced, so it might include a boiler or furnace replacement, a new refrigerator, insulation in the attic, floor walls, LED bulb replacement, and a whole lot more. And it's a really great program. It doesn't cost anything. It go up to 80% of the area median income. And so here's what I have. I listed this right here. If you qualify for the program, or if you know someone that qualifies for the program, please let them know. This is one of the best programs that is available in Colorado. It's available in your area, and it is so important during this time to make sure that we're taking care of the ones that need it the most. So that's sort of my plug for the IQ program. Again, Jake and Kim at EcoAction, contact them. They'll have it right away. Wiley and Terry at SMPA. Or myself at Tri-State. I'll help get you connected to the right people. This is my email address down here. Please feel free to email me any questions. I'm happy to, I'll be sending out the presentation. That's happy to help support this market transformation. And I'm really excited that I get to work with such great people at SMPA and EcoAction. I've got a couple questions here at the end. So I will go ahead. There's another question on heat pumps for in-floor heating. I did have a slide on that. I will also be, I'll send out a big diagram on how that works for those radiant floor heated homes, as well as I will have the 5 manufacturers that offer that product that I'm aware of. Again, if someone knows of somebody else, I will let you know. The nice thing about Arctic was one of those air to water. Their Colorado rep is here in Boulder. His name is Hans. He's a really good guy. And they also help do the heating load calculations on their equipment. So it's a pretty good setup. I haven't worked with the other ones, so they could be just as good. I just have personal experience with the one company. And with that, it's 7 o'clock. I don't see any other questions. I'm just really happy that you guys were able to join tonight. As always, again, you have my email address, and you have a great team at SMPA and EcoAction. So thank you for being here. And I will stay on here for 1 second. Is there test installation underway in the area? We actually stopped, we had one in Cortez, one in Bayfield. I know there was one, close, but not in your territory. We know they work, so we're just funding them now. If you do have some deeper questions, give me an email, and we'll talk about, maybe we can find some good information. Oh, Jake just emailed me. There's actually a test location in Mountain Village. So I think that's probably the coldest place in SMPA's territory. So I will connect Jake with you, and he'll tell you about that test installation. All right. Thank you very much.